Hello, geometry. Welcome to 2.3, apply deductive reasoning. First thing I want to show you, aside from the learning target, is this right here. This is the notation for hypothesis and the conclusion, so for your regular statements. And this means you switch them around. That little tilde is negation, means not the conclusion, not the hypotheses. Not the hypotheses and not the conclusion, and then the contrapositive, you switch those around. Okay, so here we go. I can use inductive reasoning to form a conjecture, and I can use deductive reasoning to form a logical statement. So let's start with the warm-up. I'm going to go ahead and highlight my statements so I know what I'm working with here. This is just a reminder of what we did last class. All right, so first of all, my statement is PQ. So obviously, if you go skiing, that's your hypothesis. Then you'll break your leg, that's your conclusion. So, all right, the converse, Q then P. So that means we switch them around. So if you broke your leg, then you went skiing. It doesn't matter if the statements are true or false. Okay, we're just following through with the definitions here. The inverse, this little tilde means not. So not your hypothesis, not your conclusion. So that's your inverse. So if you don't go skiing, remember that's my hypothesis. Okay, so I wanted to negate that. Then you won't break your leg. Y-O-U-R, sorry. And then contrapositive, you switch them and negate them. So if you didn't break your leg, then you didn't go skiing. All right, so a little bit of a review. Sorry about that glare. Here we go. Deductive reasoning. Deductive reasoning uses facts, definition, accepted properties, and the laws of logic to form logical argument. This is different from inductive reasoning, which uses specific examples and patterns. Okay, so we're actually using stuff that we know. Here we're just looking for patterns, making conjecture. All right, so your key concept, laws of logic. Law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion must also be true. Okay, and then law of syllogism. If hypothesis P, then we have conclusion Q. Then we have if hypothesis Q, then conclusion R. If hypothesis P, then conclusion R. So it's kind of like if we have this, then we have that, and then if we have that, then we also have this other thing. So basically, these arrows I have mean I'm going from here to there. If I have these, then the statement's also going to be true. So you'll see a lot of this. Okay. Substitution is used for a lot of this. Okay, here we go. Example 1. How are we going to use this? Use the law of detachment to make a valid conclusion in the true situation. So if you go swimming, then you'll get wet. You went swimming, so you got wet. Yeah, I know, it doesn't seem much, but moving on to the next one. Two congruent angles have the same angle measure. Measure of angle 1 is equal to measure of angle 2. So what can you tell me? Now remember, this is for the same measure. That means I know that angle 1 is congruent to angle 2. Okay, I get it. I used to hate these sections, but hang in there. This is a nice short video. All right, example 2. Use the law of syllogism to write the new conditional statement that follows the pair of true statements. Okay, so if you study, then you'll pass the exam. If you pass the exam, then you'll pass the class. So if you study, then you'll pass the class. Basically, you're kind of just skipping the middleman, so to speak. So now, going back to the formula itself, remember, if you have P, then you have Q. If you have Q, then you have R. So if you have P, then you have R. So basically, you're skipping the middleman. So let's look at example B. If a straight angle is bisected, okay, remember, straight angle is 180 degrees, bisect means cut in half, then each angle is 90 degrees. If each angle is 90 degrees, then it is a straight angle. So if a straight angle is bisected, then it forms two right angles. So we just skip the 90-degree part. Okay, two right angles. Example 3. Decide whether inductive or deductive reasoning is used to reach a conclusion. Keep in mind, inductive, you're looking for patterns and stuff. Deductive, you have information that's actually true. So, this weekend, the sun was shining and it did not rain. So the next time the sun is shining, you know it will not rain. This is inductive. Remember, inductive would be patterns, and deductive are facts. Okay, let's look at B. Let's dot that I here. The product of two integers is always even. Because 92 and 14 are even numbers, the product is even. So that would be deductive. Based on facts. So the product of two integers will always be even. So there you go. How about C? The three tallest peaks in the Rocky Mountains are 1,400 meters, almost 4,400 meters, and again almost 4,400 meters. The three tallest peaks in the Appalachians are 2,000 meters, 2,000 meters, 2,000 meters, give or take some. Make a conjecture that compares the Rocky Mountains to the Appalachian Mountains. So we actually have facts here, so this will be deductive. Remember, they weren't asking other information. They just want to know is it deductive or whatever. Here is our homework assignment. Everybody have a nice evening.